involves both a square root and a denominator. Now there are two things I need to worry about. I need the denominator to not be equal to 0, and I need the stuff inside the square root sign to be greater than or equal to 0. From our earlier work, we know that the first condition means that x is not equal to 3 and x is not equal to 1. And the second condition means that x is less than or equal to 3/2. Let's draw both of those conditions on the number line. X is not equal to 3 and x is not equal to 1 means we've got everything except those two dug out points. And the other condition, x is less than or equal to 3/2, means we can have 3/2 and everything to the left of it.
Yeah.
Now, to be in our domain and to be legit for our function, we need both of these conditions to be true. So I'm going to connect these conditions with an and. And that means we're looking for numbers on the number line that are colored both red and blue. So I'll draw that above in purple. So that's everything from 3/2 to 1. I have to dig out 1 because 1 was a problem for the denominator. And then I can continue for all the things that are colored both colors, red and blue. So my final domain is going to be, let's see, negative infinity up to but not including 1 together with 1 but not including it to 3/2, and I include 3/2 since that was colored both red and blue also. In this video, we talked about functions, since that was colored both red and blue also. In this video, we talked about functions, how to evaluate them, and how to find domains and ranges. This video gives the graphs of some commonly used functions that I call the toolkit functions. The first function is the function y equals
The toolkit.
x. Let's plot a few points on the graph of this function. If x is 0, y is 0.
That means it's crosses
If x is
directly
1, y is 1,
from here to here.
and so on. Y
Yeah, this is exponential, so it will be like y equals. It will be like this, so like exponential. This is like super exponential. This is actually gonna be y equals x. It will go like this, I think. No. How did it go? I forgot. So 0, 0, 1, 1. 2 will be like, what's the square root of 2? Oh, it will go up, but it will go up like slowly. Okay. So like this will almost plateau, but it, yeah. Like this. So like 4 will be 2. 6 here. 8. 9 will be. Now will be here, and it will be like here. Yes, it will be like y. So it will be like this, this, and so and this. So like boom, woo, woo, like boop, 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 boop. This is you cannot have negative this.
y is always equal to x.
2 times 2 to the power of x. That's gonna be real exponential. That's gonna be like a straight line, real quick. Up. For example, 3. So 0, that will be here. 1, that will be here. 2, 2, that will be here. And it's gonna like, whee! Yes, and it's also, I think it's gonna, so -2, that will be 1.5, so it cannot be negative because, well, 2, it will be like 2 to the power of -1, it will be 1/2 so -1 be half. So like here? No. So like here. And it's gonna be, it will come really, really close to 0. It will be like this, and it will like come up here, and then 0, it will be here, it will be like ooh, and then whoop, just jump.
It doesn't have to just be an integer.
1/x. It will get really, so 0. No, there's no 0. So 1 is 1. 2 is half. 3 is third. So it's really gonna come close to 0, but it will go like
It can
oof, this is gonna be even worse. Just
be any real number.
There,
and we'll, connecting the dots, we get a straight line through.
It will go like this. Does not exist here at this point, and it will stop here. No, come as close as possible. Stop here. Reappear here, and then it's the same here because it's just
the origin. Let's look at the graph of y equals x squared. If x is 0, y is 0, so we go through the origin again. If x is 1, y is 1. And if x is -1, y is also 1. The x value of 2 gives a y value of 4, and the x value of -2 gives a y value of 4 also. Connecting the dots, we get a parabola.
yeah.
Notice this function is an even function. That means
This will even, but it will go like this and then like this, you know?
it has mirror symmetry across the y-axis. The left side looks like exactly like the mirror image of the right side. That happens because when you square a positive number like 2, you get the exact same y value as when you square its mirror image x value of -2. The next function, y equals x cubed, I'll call that a cubic. Let's plot a few points. When x is 0, y is 0. When x is 1, y is 1. When x is -1, y is -1. 2 goes with the point 8 way up here, and an x value of -2 is going to give us -8. If I connect
like
the
this.
dots,
Yeah.
I get something that looks kind of like
said
this.
I said that.
This function is what's called an odd function because it has 180-degree rotational symmetry around the origin. If I rotate this whole graph by 180 degrees, or in other words, turn the paper upside down, I'll get exactly the same shape. The reason this function has this odd symmetry is because when I cube a positive
But I'm a creep. I'm a hell.
positive number and get its y value, I get, and cube the corresponding negative number. To get its y value, the negative number cubed gives us exactly the negative of the y value we'd get with cubing the positive number.
Yeah.
Let's look at the next
Similar.
example, y equals the square root of x. Notice that the domain of this function is just x values bigger than or equal to 0, because we can't take the square root of a negative number. Let's plug in a few x values. X is 0 gives y is 0, x is 1, square root of 1 is 1, square root of 4 is 2, and connecting the dots, I get a function that looks like this.
Yeah. It will plot.
The absolute value function is next. Again, if we plug in a few points, x is 0 goes with y equals 0, x is 1 gives us 1, the absolute value of negative 1 is 1, 2 is on the graph, and the absolute value of negative 2 is 2. I'm ending up getting a V-shaped graph.
Beep,
It
boop.
also has even or mirror symmetry. Y equals 2 to the x.
That will be real. Like so the negative ones are gonna be like coming from as close to 0 as possible. Coming from as close to 0 as possible. So half, 0, 1. So here, like ooh, and 1, and after that I think so 1 will be 2, 2 will be 4, and then exponentially just 3 will be 9, so like here, so like
Is what's known as an exponential function. That's because the variable x is in the exponent. If I plot a few points, two to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 to the minus 1 is 1/2. I'll plot these on my graph. Well, let me fill in a few more points. So let's see, 2 cubed is 8, that's way up here,
Yeah.
and negative 2 gives me 1/4, 1/8.